Okay, kids, the last of the homeworks. Lewis dot diagrams, and then we're going to describe the bonds. C2H6, carbon makes a bond to carbon, and then each carbon makes 3 bonds to 3 hydrogens. The carbon to carbon bond is a single, non-polar, covalent, and these are all single polar covalent bonds. Does the molecule have radial symmetry? That means, can you cut it in half in every direction like a pizza? Yes. So is the molecule polar or nonpolar? When it's got radial symmetry, that means it's a nonpolar or balanced shaped molecule. Ni3, N has 5 valence electrons, like that. I'm going to put an iodine, an iodine, and iodine. Now, iodines have 7 valence electrons, so I'm going to squeeze in a whole bunch of them. And now when we look up the electronegativity values for nitrogen, nitrogen has a number 3.0 electronegativity, and the iodine is 2.7. So we have three single polar covalent bonds. Does the molecule have radial symmetry? Well, if I cut it in half this way, we have an iodine and 2 electrons, and here we have 2, so no, and that makes it a polar molecule. No means polar. If it does not have radial symmetry, that makes it polar. Now for this next one, phosphorus with 2 hydrogens and a fluorine. Now, think about it. Hydrogens only have a single electron. They can't be in the middle. They're like attachments. Fluorine has 7 valence electrons. It can also only make a single bond. We have to put the phosphorus in the middle. I'm going to put the phosphorus in the middle. And how are we going to do this? Phosphorus has 5 outermost electrons. So like nitrogen, it's going to have 2 dots and then 3 singles for 3 bonds. Now, it doesn't really matter where I put the hydrogens or fluorine. I'll put a hydrogen on this side, and I'll put a hydrogen on the bottom. And on this side, I'm going to put the fluorine that has 7 valence electrons, 2, 4, 6, plus 1 in the middle. Now, phosphorus to fluorine. Fluorine has a 4.0, and phosphorus, element 15, is just a 2.2. So this is a single polar covalent bond. And the pH bonds right here, P and H are both 2.2 and 2.2. So here we have 2 single nonpolar covalent bonds. So there's 3 bonds altogether. One's a single polar covalent, this one's polar, and these 2 are nonpolar. Does the molecule have radial symmetry? Well, if we cut it in half, we have H and F on one side and H and 2 electrons. So the answer is no. That makes it a polar molecule. CH3Br. Carbon can make 4 bonds. Each hydrogen makes 1. Bromine makes 1. So we have to put the carbon in the middle with 4 open electrons. I'll put the bromine on this side with 7 dots. And then each hydrogen is going to come in over here. Now, carbon and bromine. Carbon is a 2.4 electronegativity. I'm sorry, 2.6. My mistake. And bromine, I have to look that one up because I don't remember it. I haven't been playing this game for a long time. Bromine is element number 35, and it's a 3.0. So this is a single polar covalent bond. And the CH bonds, we've already checked them, and we remember this single polar covalent, and there's 3 of them. Does this molecule have radial symmetry? Well, if we cut it in half, we have a bromine and a hydrogen on one side, 2 hydrogens on the other. The answer is no. So this molecule is polar as well. Okay? Water. No thinking. You just have to remember this one. It's bent. This is going to be a single polar covalent. There's two of them, one HO and the other OH. Does this molecule have radial symmetry? No, one side is electrons, one side's hydrogens. This is a no, and that makes it a polar molecule. And you have to remember that water is a polar molecule. It's always a polar molecule, and because it's a polar molecule, there's life on Earth. It's that important. Water is bent and polar, and never forget that. CO. Carbon has 4 dots. The oxygen is supposed to have 6. I'm sorry, the oxygen has 6 dots. I'm going to draw 4, and then I'm going to put 2 more in the middle that came from the oxygen only. We could also draw it like this. All right? Carbon is at 2.6, and the oxygen's 3.4, so we have a double polar covalent plus the coordinate covalent. This is a special one. Got that unusual bond. It does not have radial symmetry. Look, one side's carbon and one side's oxygen. That makes it a polar molecule. CBr4, kind of like CH4. We put the carbon in the middle with 4 dots, and then we're going to put the bromines all around like this. Now, each bromine, pain in the neck that it is, has 7 dots. So we have to draw in all of these dots in order to be legit here. We got to make sure we get all the dots drawn so that we show we know what we're doing. So we have 4 bonds. Now, bromine and carbon. Bromine is at 3.0, and carbon is 2.6. So we have 4 single polar covalent bonds. There's 4 of them. One here, one here, one here, and one here. There's 4 single polar covalent bonds. Now, if we cut it in half in any direction, like a pizza, yes, it's a non-polar molecule. The bonds are polar, but they balance out. The last one, carbon has 4 dots, and each oxygen is going to have 6. And you're going to just memorize this. It's going to look like this: oxygen double bonded in a straight line. There are 2 double polar covalent bonds. But look, if you cut it in half in any direction, yes, it's a non-polar molecule. Double polar covalent bonds, but they're both on the left and the right. They're balancing each other out. The molecule itself is non-polar.